Hi, AB Calculus class. We are working on 2010 number 6. It's a separate and integrate question. It's going to be one of your questions that are on your quiz later this week. And they give us two things to begin with. They give us dy dx and some initial point, and then they also give us the second derivative. Okay. Just so you know, on your quiz or something, they might not give you this. They might want you to find this. How would I get from here to here? Well, you'd have to you do not need to do this for this question. I'm just showing you because you'll be thankful. If somebody said to take the derivative of this, you'd have to do the product rule. You'd have the first piece times the derivative of the second piece. The derivative of y to the third is 3y squared times the chain, dy dx, plus the second piece, y to the third, times the derivative of that piece, which is 1. And then you would have to go back and substitute that. So here you can see right now we have 3xy squared, but if you replace dy dx and put it here, and then at the end we have y to the third, you should notice you could take out a y to the third, and that would leave you with a 3x. Well, there's an x here and an x here, so it's actually x squared. And then there's still a y squared, and then you took all of these out, so you're left with a 1. And notice that's the same exact thing. You do not need to do that for this question, but it is definitely something you might see on the AP exam or on your quiz. Okay, so let's go ahead and look at part A. Part A asks you to write the equation of a tangent line at x equals 1. Well, to write the equation of a tangent line, you need two things: a point, which they give us. 1, 2 is the point they gave us, and a slope. The slope is simply dy dx. And this is our dy dx, and we're going to plug in the point. So our slope, specifically at 1, 2, the x is 1, the y is 2, and we get 8. And we take the point and slope and write the equation in point-slope form. Y minus y1 equals m, and then x minus x1. So pretty easy points there. And I believe that's it for part A. Now part, no, is it? Yeah, that's all they want. Part B, that's what they want. Part B, they want you to go a little bit further. So all of this is all part A. So what does part B want us to do? Well, part B has a lot of important steps. The first thing part B says is use this equation to approximate f of 1.1. So if somebody wants you to approximate f of 1.1, that means they want the x to be a 1, 0.1. So they want the x to be a 1.1, so we're going to go ahead and replace the x with 1.1. And then we're going to get y by itself. So if we get y by itself, it's 8, 1.1 minus 1, and then we're going to add the 2 to the other side. There's no reason to simplify. Don't simplify at all. And I'm going to be fancy. Instead of just leaving it y equals all this, I'm going to replace the y with f of 1.1. And that's approximately what it is. Now, that's the first part. The second part of this question says, hey, is this answer we just got an under or an over estimate? Well, tangent line approximations depend on the concavity of the graph. If a graph is concave up, tangent lines are underestimates. And if a graph is concave down, notice the tangent line is above, they are overestimates. So if we want to know if it's an under or overestimate, we need to know about the concavity. Basically, concave up, second derivative is positive; concave down, second derivative is negative. And that's the only reason why they gave us this equation. So what we're going to do is we're going to go ahead and look at what we'll get here. Now, all we need to know is this going to be positive or negative. And they give us some information. They say in this interval, f of x is always greater than 0. But remember what f of x is. F of x is y. So y is greater than 0 means y is positive. Imagine putting some positive number here and some positive number there. You put a positive number there, a positive to the third is positive, a positive squared is positive. And now our x's. Well, our x's, in this problem, we want the x's to be nearby these numbers, where we're using the tangent line is using it for somewhere near between 1 and 1.1. Now, so imagine x is just some positive number. So x is also positive. So if the y's are positive and the x's are positive, then you can see that this is greater than 0 as long as the x's are nearby. So if the y is positive and the x's are positive, this is positive. So we'd say this is greater than 0. So we would say because f is concave up, and now we go remember our conclusion, tangent lines give underestimates. Underestimates. Okay? Tangent lines give underestimates. Or in other words, we should have said, so f 1.1 is an underestimate. I got a little wordy there, and I'm sorry. And that's part B. So part A and part B are over. Part C is where 5 points out of the 9 are. Separate and integrate. So let's go to the separate and integrate part. So part C. First of all, how do I know part C is separate and integrate? Find the particular solution. They will either say find the particular solution or solve the differential equation. Find the particular solution or solve the differential equation. Those two things mean separate and integrate. It's going to be on your exam, I think. Who knows? So, I need to take this equation right here, and step number 1 to separate and integrate is to separate the variables. You know the dy is going to stay put, and you know the dx is going to multiply to the other side. Well, the x is already over here. It stays put. And then here we have the y to the third, and it's going to have to divide to the other side. Okay. Now at this point in time, I want to take the antiderivative. Before I take the antiderivative, I'm going to go ahead and move this y to the third to the top and make it y to the negative third. Okay. So we separated, that's 1 point. Integrating is worth at least 1 more point, maybe 2. So I add 1 to the exponent, multiply by the reciprocal. And on the other side, I add 1 to the exponent, multiply by the reciprocal, plus c. If you do not put plus c, you can make, I think, 2 out of the 5 points. It's a disaster. You got to put plus c. All right, I'm going to rewrite this now. So this is now negative 1 over 2y. I just brought this to the bottom. And why did I bring this to the bottom? I brought this to the bottom because I need to plug in something into here, and I didn't want to plug it in right here. You see, I'm supposed to plug in the ordered pair 1, 2. You see up here where they said f of 1 is 2? I got to plug in a 1 and a 2. And it's going to be much nicer to plug in for a 2, not here, but there. Okay, when I do this, over here I have negative 1/4. Over here I have 1/2. And if I add, I get c is, not add, if I subtract it to the other side, I get c is negative 3/4. And I'm looking online and they got something different. What did I do? Oh my word. I'm so sorry. Wow. There's a squared. There's a squared. There's a squared. So that's an 1/8. Unreal. Okay, so now when I subtract the half, I get negative 5/8. I'm so sorry, folks. Alright, so I'm going to take this c that I got and plug it back in. Actually, I'll probably plug it back in to that version, right there. Okay, so I have negative 1 over 2. Alright, I got the y squared down here. I'll just leave it down there. 1/2 x squared minus 5/8. Alright, I'm going to make this ugly. I just got to get my final points. That's all I really want. Okay? First thing, I'm going to get rid of this negative. So I'm going to get rid of this negative by dividing everything by negative. Okay. I'm just trying to get points here, okay? I want to get y by itself. So now I'm going to do the little trick where I flip and flip. Now this is going to be ugly when I flip. Actually, you know what? Let me multiply this 2 to the other side first. So I'm just going to multiply the 2 to the other side. If I multiply the 2 to the other side, I now have 1 over y squared equals, if I multiply that by 2, that's just a negative x squared. And if I multiply that by 2, oh, that should have been a positive from earlier when I multiplied by a negative. I'm doing bad today. Bad Python. Okay. When I multiply this by 2, I get 10 over 8, which is 5 over 4. Okay. Now I'm going to do the flip, flip. If I flip, flip, I get y squared is 1 over all this stuff. And I know it's ugly. I understand this. And then my final step, I'm going to get rid of the square by square rooting. And I get y equals, so I square root and I square root. And I know that looks absolutely horrible. Now, one small thing, when I go to square root, I actually get a plus and minus in front. But a long time ago, we're talking February, back when we could roam the streets, when you square root and you get a plus or minus and you have to decide which one, you go all the way back to your y. Was your y positive or negative? My y is positive, so I'm just going to keep the positive value. And there we go. So it's an ugly answer the way I chose to write it, but it is correct. Okay. Hope you enjoyed the video. Sorry about the mistakes. Bye.